solving word problem involving trigonometric ratio. So when we say angle of elevation, that is an angle formed by a horizontal line and the line of a sight, a point above the line. For example, in the diagram that we have in the screen, angle of elevation is the angle that is inside of a triangle. Okay. That is angle of elevation, elevated. And angle of depression, that is an angle formed by a horizontal line and a line of a sight, a point below the line. It's like angle 2. It's the angle of depression from the plane to a tower. It means one angle of depression, that is the angle outside of a triangle. You still remember transversal angle when you were in grade 8 or grade 9? The transversal angle. Transversal angle composed of a two parallel line cut by a transversal. That is transversal angle. It's the same concept with the angle of elevation and angle of depression. Angle of elevation are the angles inside of your parallel, inside of the parallel line, while the angle of depression is outside of the parallel line or outside of the triangle. That is angle of depression, wherein you are looking at the top of an object or of a place down. That is angle of depression. Angle of elevation, looking up. Okay. So for example, we have this diagram. So for example, we have this figure and the screen wherein a man is looking at the tree. So we're going to identify which one is the angle of elevation and angle of depression. Looking at this figure that we have, angle 1 is the angle of our depression. Since angle 1 is outside of a triangle, or it's at the top of a tree. This is angle 1. This is angle of depression. Our main triangle is the site of a man and the width where the man is standing from the tree. This is our original triangle. So angle of depression is angle 1 since it's outside of a triangle. And angle 2 is your angle of elevation. Angle 2 and angle 3. So let's try to solve, for example, this one. We have the Seattle space needle casts a 67-meter shadow if the angle of elevation from the tip of the shadow to the top of the space needle is 70 degrees. How tall is the space needle? Ground to the nearest meter. So for example, that is the word problem that we have. We're going to draw this word problem. It says here that a needle space has a shadow, creating a shadow of 67 meter, which is this one. This is the needle that we have, which stands for Y. And the shadow that it produces is 67 meter. And looking at the top of a needle space that causes of 70 degrees angle. So we need to know what is the height of the needle. So given that we're looking for the height, which is y, means we're going to use a trigonometric ratio that we have. Looking at the given, we have an angle and a 67 meter. What trigonometric ratio is applicable to solve for the height of the needle?
Cosine.
Cosine. We have cosine. Cosine has a ratio of opposite over hypotenuse. Am I correct? opposite over hypotenuse. That is the trigonometric ratio of our cosine. Looking at the value and the given that we have in the diagram, is it correct that we can use cosine? Meron ba tayong given
No.
for hypotenuse? Do we have a measurement for the hypotenuse in our diagram? We don't have, so we cannot use cosine since hypotenuse
Sir.
is missing. So what trigonometric ratio is applicable to solve this problem?
Cosine.
Tangent. That's correct. Or cotangent is the inverse of tangent. You're going to use tangent since tangent has a ratio of opposite over adjacent. Since the given that we have is an angle, which is 70 degrees, a 67 meter, and y, that is the missing side of the triangle that we're going to solve, which is the height of our needle. So tan 70 degrees equals to the opposite, which is y, divided by the adjacent, which is 67 meter. So cross multiply. So tan 70 degrees times 67 meter, which is equal to the height of our needle. So tan 70 times 67 is equal to 184 meter. So that is the height of our needle using the angle of elevation. So in angle of elevation, it's more on the trigonometric ratio that we're using is more on tangent. Tangent or cosine. If we have a value for hypotenuse, that is the only um, thing that you can use for angle of elevation. Sometimes we use sine if what we're looking is the hypotenuse, if the given is the adjacent. Okay, so that is for the example that we have for the angle of elevation. So let's have another example. Can I clear this one? Okay na? So for example, suppose the plane is an altitude of 3,500 feet and the angle of elevation